Today we're going to add fractions and subtract fractions later on. Today's just add. But in order to add fractions, now I want you to write this down and I'll tell you again. But in order to add or subtract fractions, you must have the same denominator. You must have the same denominator. It's called a common denominator, means the same denominator. You need a common denominator. You'll hear the phrase common denominator much more than you will same denominator. Okay, repeating that. Anytime you add or subtract fractions, you must have same denominators. If you don't, if the problem doesn't have common denominators, we're going to have to figure those out. That's why the first thing today we're going to do is figure out how to find the least common multiple. LCM, you're going to see it. Now for me, there is a greatest common factor that we'll be doing later in the polynomial section, and a least common multiple, and I would always get those mixed up. So I'm going to try to separate those so that you guys can remember, okay? Now, the least common multiple, the actual definition of a least common multiple is a number that is at least as big as the smallest one, okay? It has to be bigger than this because we're going to find the least common multiple between these two, okay? It has to be at least the 15 or bigger. It has to be at least this big. We're not looking for a little number. We're looking for bigger number. When it says least, that's very misleading, okay? We want the smallest big number that both of these will divide into, okay? That both of these will divide into. Least common multiple means I need a bigger number, the smallest bigger number, okay? So, I'm sorry, say?
That would be a 5.
Now see, that is the greatest common factor. And that's where we get mixed up, okay? The least common multiple has to be at least this big. It has to be as big as the smallest one, and it could be lots bigger. Okay, but it will never be smaller than this. Okay, so a lot of people can look at two numbers sometimes and find out what the common multiple would be between those two. But I'm going to show you the actual steps in finding one that will make it easy when you can't see it. Okay? Now we're going to do what we call a prime factorization. Those of you that have been in my class before will understand prime factorization. They also call this a factor tree, a factor tree. And we're going to build a factor tree. And just a note for later on, when we do the greatest common factor, we're going to use a factor tree. We'll just use it differently. Now, a factor tree or a prime factorization says, I'm going to break this number down to prime numbers. So what I do is just start out, you can start out any way you want to. I want two numbers that multiply together to get 15. And so if anything besides 1, okay? And so we have 3 times 5, okay? 3 times 5 is 15. Now, as you come down this factor tree, what you're going to do is look at the 3 and say, is this prime? Now, you can tell that it's prime. You guys have a chart for primes. But you can tell it's prime because the only numbers that will multiply for this are 1 and 3. If it comes down to 1 and something, then don't do it. We don't do the ones, okay? So 3 is prime, and start to get into the habit of circling your primes, because here in a while, we're going to get to like 132 and 789, and you'll need to circle the primes to make sure that you don't get lost. So circle the primes, get in the habit of doing that, okay? And so we look at 5. Will 5 break down to any factors besides 1? The only thing left is 1 and 5, right? And so it is also a prime. Now we're going to come over here to this factor tree. And what times what gives you 25?
5.
5 times 5. And we already found out over here that 5 only breaks down to 1 and 5. And so both of these 5s are prime. You are through with the factor tree when everything along the bottom are primes. If they weren't, and we'll do some like that, if they weren't, you would keep going, keep going, keep going until you get primes all at the bottom. Okay, and you can tell quickly if you'll remember to circle your primes. Now, to find the least common multiple, what we're going to do is use every number that shows up, every different number. So we're going to use some 3s and we're going to use some 5s. Okay, so we're going to use 3s and we're going to use 5s. Okay, now what you do is you look in each tree and you say, okay, there's 1 3 in this one and no 3s in this one. I want to use the amount where it's used the most. So it's used, the most place is here, 1. Okay, so 1, 3. There's 1 3, so 3 to the first, okay? 5 shows up 1 time here, but 2 times here. So I want to use, no, you don't add them together. You decide which one is the most. And this one's the most 2 times, right? So we're going to use 2 5s. And the easiest way is to do this. Now, if you want to, you can say, I'm going to use 1 3 and 2 5s, if that's easier for you. 1 3 and 2 5s, and I'm going to multiply them all together. Up here, 3 to the first is 3, 5 to the second is 25, and you're going to multiply those. They'll come out the same answer. 3 times 25 is 75. 3 times 5 is 15 times 5 is 75. So the least common multiple between these two numbers, or the common denominator, would be 75. Now that's just the first time you've seen it. And if it's the very first time you've seen it, then we need to practice a couple more times. Because what we're going to be doing all the way through adding fractions and subtracting fractions, we have to find a common denominator over and over and over and over and over again. And common denominator is the least common multiple. Same thing, a common denominator. Okay, so you need to get practice in this. Does everybody have this example written down? Are we good?
Yes.
Okay, let's do another example. You're finding common denominators, but it's called least common multiple. Least common multiple. Let's try 16 and 45. Okay, I have no idea. This might be big. Okay, 16 and 45. So the very first thing you do is make your little t-chart, or prime factorization, factor tree. So here, you can start anywhere you want. You can say, oh, 4 times 4, or you can say 8 times 2. It doesn't matter if Simon starts at one place and Rachel starts at another. The primes will be the same, okay? Remember to circle your primes as you go. So however you started, you should end up with 4 2s at the bottom of the 16. Okay, check your work. And then notice how we didn't have one level, we just kept on going until all of our bottom numbers are primes. Okay? Let's make sure you're okay with your factor trees. Did we get the same numbers? same primes. So we don't miss any numbers. We're going to use every number that's shown, but the number of times is going to be what tells us our answer. So I see some 2s, I see some 3s, and I see some 5s. Okay, now I want to look at these individually. We're not going to add them up. We're going to find which place it's used the most. So let's do 2s. In this one, there are 1, 2, 3, 4 2s, 4 2s, and none there. So we're going to use 4 2s. Now that's not 2 times 4. It's 2 to the 4th power, which means 2 times 2 times 2 times 2. Okay? Which is actually 16. Okay, 2 to the 4th is 16. Then we look for the 3s. There are no 3s here. There are 2 of them there. So we're going to use 2. So that would be 9. And then 5s. There's 1 in that one, nothing here. So we're going to use 1. And that's 5. This is where a calculator comes in handy. And did I get them out? No. Come on up. Get them real quick. Because we're going to do this more than once. Those of you on the remote, we're just checking out calculators.
Okay.
Oh, you need another one? I love it when my class is full. I love this. And when we find out how many times we're going to use each number, then we multiply those together. Okay? And we should get, do we have an answer?
720.
Good. 720 will be your common denominator if you have to get a common denominator between 16 and 45. Okay? Let's do this one. Has everybody got this? All right, let's do this one. How about a common denominator between 12 and 72? I need the least common multiple, which means it's going to be our common denominator that we're going to use in fractions, okay?
One.
Bless you.
Thank
I'm spending extra time on this because a lot of times teachers just skip over this and then you struggle finding common denominators. There will be times you'll be able to see what the answer is. This is to use when you can't see what it is. Now remember, the least common multiple that we're going to come up with will have to be 12 or bigger. It's not going to be 2 or 4. It has to be, the least common multiple has to be at least this big or bigger. Least common multiple is bigger. Okay? Check your factor trees. Make sure you came out with the same thing. Okay, now we're going to find the least common multiple or our common denominator. And that means we look at both of our factor trees and we see we have some 2s, we have some 3s. We're not going to count 4s because 4 is not prime and it's not circled. The primes are the ones that are circled. So we have 2s and 3s and that's all. Okay. So you guys tell me how many 2s are we going to use in our common denominator?
5.
3, that's correct. Because I have 2 of them here, but I have 3 of them here. So that's the most. I want to use 3 of them. 2 to the third is 2 times 2 times 2. Your calculator will do this for you. 2 times 2 times 2 is 8. 2 to the third. And then we have some 3s. How many 3s are we going to use? 2. Okay.
Okay.
That would equal 72.
Yeah.
3.
Least common. Oh yeah, makes sense. Okay. I had something completely different in mind. Okay, and then you multiply these together and we get 72. Will be our common denominator, or yeah, common denominator, least common multiple. Who's game to come do one? Okay. Let me get you a couple of numbers up here. And I want you to find the least common multiple between 8 and 36. Okay. This is Simon. I'll introduce Simon to you guys. Okay, good. Okay. You can use any of them, even 6 times 6 if you want. 9 times 4, 6 times 6, whatever. No, they're not prime.
Oh, yeah. Sorry.
You want to use the eraser? Just erase them completely and put them back in. Okay. Two. Good. All right. Again, perfect. So the least common multiple, thanks, Simon. That's good. The least common multiple here is going to be 72. That means if I have fractions that need common denominator, the bottom or the common denominator will be 72. Nice work. I would take one more volunteer to do one more example. Should I stare at somebody?
I'll do it.
You want to try it?
I'll try
All right. Oh, I meant to give you this. You can wipe your hands off.
it.
There's two of them. I didn't realize there were two of them.
Was that a 9? Wait,
Oh, I'm so sorry.
no, it's like, huh?
This is a 9. There were, the most 3s were 2 of them. And the most 2s, there were 3 of them. So this is an 8, and 3 squared is 9. 8 times 9 is 72. Is that all you need, or do you want me to
Yeah,
put
well,
this?
do you see on 36 right here, how I did it? Is this correct? It was 3, 3, 3, 3.
No, because 3 times 3 is 9.
Oh,
times 2.
oh,
3
okay,
times
okay,
2.
that's right. Thank you.
Very common mistake. You guys got to be careful with 6. It's so easy to say 3 times 3. It happens all the time. So you're going to try one? All right. Let's do 15 and 45. Okay. And for those of you that are remote, this is Rachel. Okay. 15 and 45. I want you to find the common denominator or the least common multiple here.
That stays the same, right?
They're prime, so circle those. Good job. Here's a calculator in case. If it ends in 5, it will divide by 5, okay? So one of them will be 5. Oh, there you go. Good job. Nice. Circle primes. I know, right? And the 5. Okay, let's list all the different numbers we see. We see a 3 and we see 5s. Okay. Where are the most 3s? Good. So there's 2 of them. Good.
And 1.
Very nice. 3's good. 9.
And 5.
So we're going to multiply those and get
45.
okay, yay. This is great. So see, it can, the least common multiple can be one of the numbers, but it can't ever be lower than the lowest number.
Miss Deborah,
Yes,
I'm sorry.
do not have to be sorry.
Okay, so she says it's 2 3s, right? Isn't that what she said?
Said 3 to the second.
Yes. Okay. So so you got a 3 on the side with the 15, and then we got 2 3s on the side with the 45. So
Yes.
wouldn't it be 3 to the 3rd
No.
power?
You don't add them up. You find where they're used the most times. So
Oh,
here it's only 1 time. Here it's 2 times. So you're going
oh,
to see
I got you now.
common
okay.
mistake. Yeah.
I'm like, there's 3 3s on there.
How are y'all feeling about that? Because if you feel okay with this process, we can move on to adding fractions. Okay? All right. Are you guys okay online? Are you guys okay?
Yes, ma'am.
All right. I've got a message here. I'm trying to get off the screen. There we go. Okay. So let's add some fractions. Now, when we add fractions, this least common multiple will come into play. Now, what I'm going to do is take us back to grade school. So if somebody gives me a problem and it's written horizontally, let's go 1/7 plus 4/7 equals. Then immediately, if it's add or subtractive fractions, I highly recommend that you write it again vertically. 1/7, you'll see why in a little bit. 4/7. Okay. I would always write it up and down. And this will be because when we have different denominators, it's very easy to do. Okay. So we're going to write it vertically. Now, before we even start, you've written it, then we look at the bottom. Remember, the bottom part is called the denominator. Denominator. Oh, almost ran out of room. Denominator. Okay, the bottom part of the fraction is the denominator, and that's why we call it common denominator, okay? Common means the same, and so the very first thing we're going to do is look at both the denominators. Here's a denominator, here's the denominator. Believe it or not, in this particular problem, they have a common denominator because the denominators are the same, right? You don't have to do anything to this problem except bring down the answer. The answer will also have the same denominator, okay? It will always have the same denominator. And then the numerator, which is the top numerator, you simply do the addition. 1 plus 4 is 5. And your answer is 5/7. That's on problems that you have a common denominator. Yes? Easy enough. Yes?
Is it before, well, it's been a while, but I used to think you added the denominator as well.
No,
No.
no. The only time we're going to do anything with the denominator later is in multiply and divide.
Okay.
Okay? This one, all we want to focus on is we have to have the same numbers on the bottom. Okay?
And that's for adding and subtracting, and then.
Yes.
Okay.
And we will not mix up multiply and divide. We will take it to a whole nother day or whatever we need to do to separate them. Because again, different rules for add and subtract, different rules for multiply and divide. Okay? So let's do this. Let's do this problem. So now it's written horizontally. I'm going to write it vertically. 5/7 plus 4/7. Okay, this will be, because it has common denominators, my answer will be 7ths, and I add the top, which will be 9. Now in this case, this is a perfectly acceptable answer. It's reduced to the lowest terms, it's simplified as far down as it'll go, okay? And a lot of our answers we're going to leave top heavy, which is improper, okay? But let's practice changing this to a mixed fraction, because we don't know on your test whether they're going to show it this way or they're going to change it to a mixed fraction. Remember, any top heavy fraction can be changed to a mixed fraction, okay? So y'all change it, remembering that this line means divide, okay? Looks like a happy face.
So change to a mixed number?
Change it to a mixed number. That means put the 9 inside the division and put the 7 on the outside. 7 will go into 9 one whole time. I want to show you that with a pie, just because I love drawing pies. Oh, let's see, let's go. Okay, again, assuming that all of these are equal. Okay, there are 7, right? Because we're in sevenths. So I divided the pie into sevenths. But there are only 7 of them here. I've got 9. So I need another pie, right? So I need another pie. Not very good at sevenths. So I need another pie that's sevenths. Okay, so 9, I have to color 9 of them. So here's 7 of them. I colored 7, 8, 9. So can you see that in the drawing part, the 7 of them represents the one whole, and then there are 2 more sevenths left over. Do y'all see? Okay, so if you are a picture person, this is what it means with the pies, that 9 sevenths went over one whole pie. And then we got some more pieces in the next one. Everybody good with this? Okay. So if you are good with adding, and the same rules apply for subtract, okay? With adding with common denominators, let's move into different denominators and find out what we need to do. What about, let's do 2/3 plus 1/2. So immediately you're going to write it vertically. 2/3 plus 1/2. Okay. Now, just like I told you a minute ago, the first thing we're going to do is look at the denominators. When they're different, you know that you cannot add them yet. They have to be the same. So what we're going to do is put an equal sign out to the side. This is the way it was done in grade school. And we've got another fraction out here. What we're going to do is create a new fraction that's equivalent to this, but it ends up with the common denominator. These will be the same, okay? Now, for those of you that have a little bit of trouble finding the common denominators, then what we're going to do is what we did just a minute ago. This one is already prime, so there's nothing to break down, right? And this is already prime, there's nothing to break down. So our common denominator is going to be 6. And so you put it under both of them because it is a common denominator. Y'all see. This is the place where you find your common denominators. Then we'll start with one fraction at a time. Doesn't matter which one. And what we're going to do is look at what happened. I like to put a little box, but you don't have to. Now, when I had a 2 on the bottom, and I'm going to 6, what did I multiply by? I multiplied by 3. And what we're going to find out in math, all of our math from now on, is if you do something to a problem, you have to balance it out somewhere. And so whatever you do to the bottom of a fraction has to be done exactly the same on top. So we have times 3 again. So the top of this is going to become 3. Do y'all see how we change to common denominators? Okay, up here, this one's not 3. I had to multiply by 2 to get to my 6. So I have to multiply by 2 here. And so now I have 4. Okay, I'm still adding, but I don't need any of this anymore. I'm going to concentrate right here and find my answer now that I have common denominators. Good. So I have 7 over 6, the common denominator, 7 over 6, which is fine. That's a top-heavy, lowest terms answer. Perfect answer. But if your multiple choice on your test is mixed fractions, then you need to know how to change this to a mixed fraction. Okay, so change it. Is there a whole pie in here?
Yeah.
There's 6 pieces, right? And then how many out of our next pie? So this is going to be
Be
equal
1/6.
and 1/6. Both of these are exactly the same value. They're just written in a different form. Okay, so both of these are the correct answer. It just depends on what your multiple choice in your test says. Are we good? Are fractions getting a little less scary? Yeah. Some of my students are still showing me the chills. They still have the chills. Okay, let's do another one with a little bit bigger denominator. Let's do 4/7 plus 2/21. We have to get common denominators. They're not. Seven is already prime. We have 7 times 3 here. So my common denominator is 21. Okay. So what did I have to multiply by here? Pardon? Just times 1 because it's the same. Times 1, so if I multiply by 1 here, I get 2. Are we good? What did I multiply by here? 3. So I have to multiply by 3 here. So my answer is, I'll come out here. We know the denominator is 21, and somebody said 14/21. Okay, now look at this. This is a good answer, but is it in the lowest terms? You always need to look.
Yes.
It is not in the lowest terms
No.
because the top and the bottom will divide by the same number. What will it divide by? 7. Divide by the same number. Now, those of you that haven't used our calculators yet, I want you to put this answer in your calculator. Now, there are 2 ways you can put it in your calculator. You can either type in 14 and the divide sign and 21 and press enter and stay there with me. Or there is a little fraction button towards the top. Do you see it? Anybody need me to show you? Simon, I think you're the only one that hasn't used it a lot in here. Do you see it?
Yeah.
Okay, you can put your 14/21 in that. Now, those of you that used the divide sign, when you pressed enter, you got a decimal. Above the enter key on the right-hand side is a button that has 2 arrows. It will change from the decimal back to a fraction, but when it changes back to a fraction, it'll change to the lowest terms for you. Okay, so if you didn't use the fraction button, do this one, Simon. Do 14 and then the divide sign and 21 and see how this works. When you press enter, it gives you a decimal. But if you use that toggle switch, it will give you the reduced or the simplified version of the fraction, 2/3. You see it? And everybody else, I think we've used it. Okay, so how are you here? You good enough? Okay, we're going to try a couple more examples that'll give you something else for page 13. We decided that the only worksheets that we're going to deal with today are 11 through 13. We're not going to go farther than 13. So, word problems, not yet. Okay, let's do 2 2/3 plus 1 and 1/8. Let's do that. So, write it up and down. 2 2/3 plus 1 and 1/8. Okay, now, what we've done in the past few examples is we looked at the bottom and we say they don't have the common denominators, so we're going to need to do that. But with mixed fractions, there's a step before that. Now, I will tell you that some teacher will go ahead and teach you how to get common denominators here, then add them up and carry, and that's fine. But I found out the simpler way is to go ahead and change this to an improper fraction, change this to an improper fraction before we find common denominators. Okay? So this is, remember, 1 times 8 is 8 plus 1. So we have 9/8 and we have 8/3. Do y'all see that we didn't find common denominators yet? We just dealt with the mixed fractions. Did I do it right? 6, 7, 8/3? Yes. Now we get common denominators. Here we go. Here's our 3. Here's our 8. 3 is already prime. 4 times 2. 2 times 2. So we've got 1, 3, and 2 to the 3rd. That's 8, and this is 3 times 8. So we're going to have 24. Is our common denominator.
So 2 times 8.
Yes, because 3, it was like 3 times 1. So
Yeah.
there's a 1, 3, and there's 3 2s.
Okay.
3 2s are 8, and 1 3 is 3. 3 times 8 is 24. That's how we got 24 for a common denominator. Now look at the bottom. What did I have to multiply here?
8.
3.
3.
3 here. And then times 8 here. 8 here, 64. Now we don't, when you get common denominators, you don't need any of that stuff over here. We've worked this to this step, this to this step, and now all you have to do is add this. We know that the answer, I'll go out here so it doesn't mess up. They have 24 on the bottom,
91 on top.
91 on top. And then you put this in your calculator and make sure that it is in the lowest terms here. If you put 91 over 24, does it still come out 91 over 24? Okay, no matter how you do it. Okay, so this is a perfectly good answer if all of your multiple choice are improper fractions. What if all of them are mixed? Change it to a mixed. Now, I want you to change it by hand, but I will tell you that there's a place on the calculator that will do it for you. Okay? And if you want to see it, I think some of y'all already know, but let's do it by hand. 91 divided by 24, come on. So it's not 4, could it be 3? It can be 3.
372.
72, 19. Okay, and we put the remainder over the divisor. So 3 and 19/24. This answer and this answer are exactly the same. Just depending 91/24 or 3 and 19/24. How are we doing? Are you filled up to about right here? Ready to practice? I don't want to drown you, so right here you can still breathe. Right? We can still breathe right here. So is this a good time to stop? Does anybody need more examples right now?
When they get big like that, it's harder.
I think
Yes.
it's like more steps, but
But you
Well,
think
so
you're okay? Let's try it and see.
yeah, we have you here.
Yeah, I'll be right here. Have y'all seen E.T.? I'll be right here. Okay, questions? Isabel, Sherry.
Yes, I was gonna ask you, where is that fraction button on the calculator?
Oh, let me show you. Okay, it's backwards, so okay, here's your calculator.
Okay,
And right here, see it?
okay, yes,
N stands for numerator and this stands for denominator. Now,
Okay.
you can do it two ways. Let me get to the on button. Okay, and let me get cleared. All right, if I'm putting in 91/24, you can
Uh-huh.
either push this first and then put the 91 in and use your down arrow and put the 24ths. You can do that, or you can
Okay.
actually, we found out that you can put the 91 in first, then hit it, and it will put it on top.
Yeah,
So it doesn't matter which way you do this. And you have to scoot over. See, anything else you type will stay on the bottom. So you scoot it over
okay, I got you.
and then press enter. And there's your 91/24.
Okay,
And I
yeah,
think it will change to a decimal, I think. This one might, yeah, there you go. You use this toggle button right here to change back and forth.
okay,
Because if I push it again, look what happens.
yeah,
It changes back to the fraction again. And when it changes back to the fraction, it's in the lowest terms.
okay,
So
I got
you'll know that's already simplified, okay?
okay, thank you.
Uh-huh.
Yes,
Anything else?
no, I don't think so. I think I got it.
Sherry?
Miss Deborah, I've been the only thing that I really had any problems with in these worksheets are the missing number paper.
Yes.
And I know you went over it yesterday. And every time I think I know how to do it, I get some of them right and then I get some of them wrong, and I don't know why I'm getting it wrong.
Can you give me a particular one that you got wrong and let me try it again with you?
Okay, like 7B.
7B. Okay,
Yes.
let me get all this out of the way.
Okay.
You know, I was going to show you guys a different way yesterday, and I didn't do it. Okay, 7B, this is how I showed you yesterday. Okay, to find the missing number, what you do is try to find out the relationship between these two numbers, the ones that we already know. So what happened here?
Well, I multiplied 5 times 6.
Okay,
Okay. And so then
But- could it also be that we took this one and divided by 6 to get here? 30, if 6 is what's different between here, if I went from 5 times 6, I got 30, right?
yes.
But do you agree that if I had 30 and divided by 6, oh, can't do that. Divided by 6, I would get 5.
Yes.
So 6,
Oh.
so 6 is the magic number here, right?
Yeah. Yes.
And if I'm wanting to go from here to here, then I need to divide. I went 30 divided by 6 gave me 5. So let's divide by 6. 6 divided by 6 is 1.
Oh, okay. Well, I was trying to multiply that 6 times that 6, and I'm like, that's
Oh.
36. And on the answer key, they got 1. And I'm like, what?
Yes. Do you understand what I'm doing here?
Yes.
Now, if all of you want to watch, I didn't show you guys this yesterday. If all of you want to watch,
I think we did go over that yesterday.
we did this like this, but I didn't show you the other way to do it. Okay, listen, all of you listen.
What's her name?
On here, Sherry,
Sherry. Tell her
Sherry.
hi.
all of
Hi.
them are telling you hi, Sherry.
Hi.
It's Irene.
Hi, Irene. How are you?
Okay. I recognize your voice.
Everybody recognizes your voice. All right. Now, yesterday we worked this and I said we took 30 divided by 6 to get here, so I have to divide by 6 and I got 1, right? If you have a fraction equal to a fraction, this is the only time you can do this. This is when you have one fraction equal to another fraction, which is that whole page, right? Okay, watch. We'll talk about proportions later. You can take the opposite sides and multiply them together. The two sides that we know, 5 times 6, and then divide it by the leftover. So we've got 30 divided by 30, and anything divided by itself, what is it? 1.
1.
Okay, and so that gives us the missing number. So you can say the two numbers that you know that are in a diagonal, multiply those, then divide by the leftover, and that will give you the answer. Is that better, Sherry?
Yes, ma'am. I
We
knew
will-
there was a trick. I just couldn't remember what it was.
This is how we solve proportions. And we'll have a proportions section later on down. So now you have just a pre-lesson on proportions. What do you think?
I think it looks a lot better.
Let's do one more and you tell me the answer, okay? And we want to know this answer right here. Notice that it is a fraction equal to a fraction. So what's the missing number?
$39? No.
39. because she multiplied the two numbers that we know in a diagonal, multiply those, then divide by the one that's left over, and you'll get your missing number.
Wait, which one's left over? Divide by which one's left over?
This was blank,
Uh-huh.
so that was the leftover. See, we multiplied those, and then the number we didn't use, we're gonna divide by.
Oh, okay, got it.
Okay.
So how do we know which one to multiply?
Because we only multiply, like, okay, if I didn't, I've got a number here, and I've got a number here and a number here, okay? So I want to draw a diagonal. If I drew the diagonal this way, I don't know the two numbers. So I will do these two.
Oh,
Do you see? I multiply the two that I know. And then the leftover number that I hadn't used yet, that's what I divide by. Is that easier?
yeah.
Okay, the reason they have this page is to help you get a common denominator, but I feel like this is easier. Okay, so go for it. Sound good?
Yep.
Okay, I forgot to show you that yesterday. So how are we now? Isabel, Sherry?
They're good. I got it.
Good. I'm good.
Yay!
Thank you.
Any more questions on yesterday's or today's? Okay, you know I love you girls.
We love you too.